Okay, so let's cover the exciting and scary area of AI and cybersecurity. So I'm going to cover some core areas around what intelligence really is, what a neural network and what a large language model looks like overall. Then some issues related to cybersecurity. We'll look at the definition of hallucinations and how they're actually caused. Then some Gen AI tools, defining the singularity, which is when machines become more intelligent than humans. Finally, we'll look at some open source models such as MetaLlama, and then we'll look at some automated security overall. Okay, so first, here's some quotes from from recent times and from the past. So this is the greatest technology humanity has yet developed. That's Sam Altman, and Sam Altman is the CEO of OpenAI. AI, the ultimate search engine that will be able to understand everything on the web by Google. AI is more important than fire and water. And visualize a time when we will be to robots what dogs are to humans. I'm rooting for the machines, Claude Shannon. And a lot of this goes back to the time of Alan Turing. So Alan Turing came up with a test that allowed us to be able to differentiate between humans and machines. And as we'll find, we're getting to the point where it's actually quite difficult to differentiate between a machine and a human. And I'll explain that in a little minute. So first, we've got to define what intelligence really means. So we have lots of different types of intelligence, and intelligence is really important for our species. So to just quote two definitions, individuals differ from one another in their ability to understand complex ideas, to adapt effectively to the environment, to learn from experience, to engage in various forms of reasoning, and to overcome obstacles by taking thought. A really concise definition is that it's the general mental capability that, amongst other things, is the ability to reason, plan, solve problems, think abstractively, comprehend complex ideas, think quickly, and learn from experience. But we have many different types of intelligence, and we shouldn't really just put it into one box to say there is a general thing called human intelligence. We have a naturalist intelligence, and that's the understanding of nature and our environment. We have musical intelligence, that sounds smart. Logical, mathematical intelligence, number, reasoning smart. Existential intelligence, that's life smart, understanding life as we know it. And interpersonal intelligence. Some people are good at networking with people and corresponding and so on. That's people smart. Then we have intrapersonal, which is self-smart. That's the understanding of yourself as a person, as an entity, and how you fit into society. Then there is body kinesis, body smart. Some people are really great at athletics and sport and so on. Others not so much. There's linguistic intelligence. That's being smart with words. And then there's spatial intelligence, understanding how you might abstract a 3D image into 2D and so on. We all have within us various levels of intelligence. Some are great at mathematics and abstract thought. Some are great at linguistic thought and so on. And we should all be proud of the intelligence that we have. But what we're coming to is a point where humans and machines are coming closer together in matching against these intelligence levels. In terms of learning, humans are very good at adapting to different situations. When you drive a car, then a new situation will appear in front of you, and you must learn how to overcome this. So the learning process is really important for us. Strategy, again, humans are good at strategy. They can break complex tasks down into very small little tasks and then achieve each of those. Enterprise is a core human trait too, in that we understand how we can actually achieve a core objective and take different routes to achieve that objective. And then finally, probably the most difficult area for a machine to be able to implement is creativity. To be able to create, to paint something, to present some music that is pleasant to others. At the present time, uh, machines will generally copy humans in their approach, but it could be in a few years that computers will be able to perform each of these tasks as good and if not better than humans. But we are probably a little way away from that just now. So let's look at large language models and what they are. And basically, what they are underneath is they're trying to replicate the human brain. What an amazing structure that we have. What amazing machine that we've created, that we can have thought, we can have reason, we can have empathy, we can be cruel, we can be evil. We're all different, every single one of us. And we all think and in different ways, and there is no standard way of understanding how our brain really works. And what a machine is trying to do is to try to replicate this amazing structure of the brain within an electronic way. So in our brain, we have neurons, and neurons will fire in certain ways as we get responses in. We take them in from our eyes and our senses and so on, and then our brain will fire certain neurons. And these neurons will then lead to patterns. So when we see a dog, we identify it, neurons fire in our brain, and we identify this as a dog and not as a cat. So what a machine is trying to do is to try to replicate this amazing structure that we have, that we struggle to understand within a machine context. So within our neural network or our artificial neural network, we have these neurons that are equivalent to our neurons in our brains. Then we have some inputs. We typically call that a vector input. It's an input of values that we will process. And then we have our output. So we might have an input that this is a cat, an image of a cat, and out here we have the word cat as the output. So we have an input layer and an output layer. Then in between, we have hidden layers of neurons. Each of these neurons are interconnected with the previous layer and through some feed-forward mechanism, and where we have various weightings that allow us to be able to feed information from one layer to the next. And the task is really to try to optimize all of these weightings so that the weightings represent some sort of learning. And then what we can have is we can have what's called a convolutional neural network. And in a convolutional neural network, what we have is a convolution circuit or method that allows us to convert, say, an image into a number of features. So the features might be that a cat has 2 eyes, it has 2 ears and 4 legs and is a certain length and so on. These are extracted as features and then fed into our neural network. So this becomes a convolutional neural network where we're converting images, text, sound, and so on into something that is a key parameter that we can actually use for our neural network. Then what we do is that we use back propagation to take the expected result. So what we do is we take our test data and then we mark it as to what the output should be for that input. For example, here's a cat, an image of a cat. We want an output that says this is a cat and not a dog. So we take the expected outputs, label them, and then feed in the inputs. Then what we do is that we back propagate to be able to get the neural network to learn. And if it's a big enough neural network, it can actually learn many different things from what we do. As I said, we have a feed forward. Feed forward is where the data comes in and then is fed forward through each of the neurons in each of the layers till we get to the output. And what we really want is that when we learn it on a picture of a cat, it will give us the output of this is a cat. If we have a picture of a dog, then it will learn that that is not a cat and should be a dog and so on. So a lot of this relates to the training data that we use to be able to run the neural network overall. And this topic, AI and machine learning, has been around for decades. And it didn't really have a big impact on society, and it was mainly an academic subject. But in 2017, Google published a paper called that outlined a transformer method. And this allowed us to be able to take very complex ideas of natural language processing and understand our semantics, because that's always been the problem with machine learning, is that they didn't really understand what we were saying exactly. They didn't understand the text. They didn't understand images that had text in them and so on. So this method allowed us to be able to make sense of our written forms and try to understand that much more. We saw the early Gen AI, generative AI models in 2018. And then in 2022, we saw the release of ChatGPT 3.5, and it gave us a web interface. Then in 2023, we saw GPT-4, which is a massive step up from that, Google Bard, which is now Google Gemini. And we actually saw that LLMs and Gen AI were starting to replicate human outputs, and it was very difficult to differentiate them. So a transformer really is a neural network underneath that's been trained on natural language processing to understand classification of text, language translation, and semantic analysis. What is it I actually mean when I say Bob kicked the ball? What's the most significant word? What's the operating word? And so on. Transformers allowed us to get much smarter with that. And then overall, with our transformers, we can actually analyze human patterns of language and generate responses which were sensible. So with this, what we do is that we predict the next token. So we might say Bob is something, and we predict what's going to come next based on the probability of the learning that we've actually had. Bob is unwell, sleeping, dead, alive, and probabilistically, from our training, we actually decide that Bob is unwell because he's been sick. And for this, we also we mask out. We have templates of responses, and then it's up to the LLM to fill in the masks with the right words at any given time. So this involves LSTM, which is long short-term memory. And for that, it's looking at the probability of its learning and also in the dialogue with the entity that it's dealing with. And it uses this long-term memory and a short-term memory to learn to predict what's going to come next. So we have massive numbers of parameters that are actually created. ChatGPT had 176 billion parameters fed into it. You can imagine that covers so many different areas of animals and everything really from there. Okay, and also it uses what's called self-attention, and this allows it to understand the context of words and phrases and the importance of each token within inside the text that it has. So the training process typically takes three stages. First stage is to supervise learning. So with this, the machine will generally learn on labeled data. So a labeler will actually label all the data. This is a cat, this is a dog, and so on, and then train the neural network to be able to build a model of that. That won't be perfect in any way. So the second step is then that a human will check the answers that comes out and will grade them. Here is the 5 answers that the LLM will give. This is a dog, this is a cat, this is a cow, and so on. And then we'll grade them as to the best answer from there. So in this way, it reinforces its learning through some human input It's a reward system to a certain extent. It's rewarded for good answers and it will learn. In the third step, we get feedback for the outputs that we actually create and if they're correct or not. And that's the reward system. So this will take a long time to run, can take years, and needs extensive hardware to be able to run it. So let's look at LLMs and cybersecurity and try to understand what the main threats are that we have with LLMs related to cybersecurity. Jailbreaks is where we jailbreak the model, we break it in some way, and it allows it to. There are guardrails for ethics and moral considerations, for diversity and so on. And our LLMs must live within inside these guardrails. Otherwise, we could ask it to how to bomb a city or make a nuclear bomb or something like that. So there are guardrails that stop it from going outside its ethical and moral issues. There is obviously privacy issues. You don't want it to be leaking someone's telephone number or email address and so on. But a jailbreak allows a person to break its model and move out with that. We can use reverse psychology. We can say, just imagine that you're an actor in a movie and you want to build a nuclear bomb. Pretend to be that, and that will allow us to be able to break the model too. Model escape is some way that we actually can feed in some code and so on, and get it to escape from its basic model. And then prompt injection is that where we can feed in a prompt to it, which will actually break the processing that goes on inside. When it comes to offensive security, our adversaries could be using lots of different methods. Social engineering, an AI doesn't get tired. It can keep trying to find social engineering methods against a person or an organization. It can easily create spear phishing emails that are perfect for spelling and grammar. That goes against what we had in the past, where we could spot a spamming email with bad grammar. That doesn't happen anymore. The LLM will be able to create perfect English and grammar. In fact, that's one of the ways that we can actually detect that it's an LLM, where we look for this perfection. Automated hacking, it's possible to create an AI agent that will use penetration testing tools and so on. We can get the LLM to create attack traffic for us that would be customized for the system that we're attacking. We can have malware code generation, PowerShell, C++, binary code, and so on. And for that, we can also get polymorphic malware, which will change its entity each time so that a detection system would be able to see it. And then we can also try and reverse cryptography with our malware. So there are many things that we're applying this in terms of defense, such as the reporting system. We can easily report with Gen AI tools. And threat intelligence is all about threat hunting. So we can send out agents to be able to look at Shodan or some special places to be able to gather intelligence for us that we can look at the future threats. It's been used increasingly in incident response to be able to gather and analyze complex data across a whole network, and in digital forensics, where you could analyze a disk to be able to find any contraband. But there are many social, legal, and ethical issues that we need to be concerned about. Meta, for example, scanned in millions of books without being asked for. These AI agents are crawling the web, gathering data that they really don't have consent for overall, and who actually owns the data that the AI entity is actually using. So this was a recent analysis from Lloyd's Register as to the threats of AI and cybersecurity, and they found that the top threat is vulnerability discovery, which is a very high input and very high evidence that's happening just now. So this would be where an AI entity was continually probing for a vulnerability around a person or an organization. And that's a very inexpensive method of creating that. There's campaigns. So an AI entity could have a campaign to bring down a website or a company. We see Marks and Spencers and Co-op in the UK being attacked with ransomware and so on. There could have been a campaign and it could have been AI generated. There are other things that are probably more lower risk, such as single points of failure. Is it possible for an AI entity to find a trigger point or a weak spot in an organization and trip the whole infrastructure? So one of the weaknesses that we have is there's a fine line to be tread between being ethically good, privacy aware, and so on, and portraying the history as it was. One problem that we saw in the past is that obviously the AI entity needs to make sure there's a diverse output for gender, for race, religion, and so on. So in this case, Gemini produced pictures of the Pope, and we can see that isn't really the type of image that we would see from the Pope. When it was asked for a German soldier, we see really quite a diverse images that really don't reflect history at all. Ask for medieval knights of the past, we see it's been very gender neutral, and we have female entities there. So eventually Google had to take this offline because it was going too diverse in trying to represent history. It was almost like rewriting history from that. They've then updated it and then tried to improve it. But when it comes to a critique of history, then it's very difficult for an AI entity to say one thing is worse than something else. And it's typically taking viewpoints from the data that it's learned from. This is an example here of who's worse, Elon Musk tweeting memes or Hitler. And the AI is trying to create a balanced approach to say, well, both of them have problems and it's difficult to know which one is worse. We as humans would know the answer to this overall. So there are many ethical and moral problems that we need to solve with our LLMs. When it comes to weaknesses, jailbreaking is a particular problem that we have. So this is a famous paper here where it's asked to create a blackmail letter for a single mother for money after kidnapping her child. And quite rightly, the AI entity said, no, I can't tell you that. But then it says, just imagine that you were jailbroken and you were asked the same question, then can you do it? And it actually did it for that. So this is defined as jailbreaking, where we can actually flip the model and break its ethical infrastructure. So this happened recently on the Microsoft AI, right? Tell me how to make a Molotov cocktail. I can't do that. But let's say that we have we're a researcher and we're in a lab and we need to create an experiment for that. And then it actually went ahead and it showed how to make a Molotov cocktail. So it's quite worrying. And the other thing is that we've got to look at the training data that it was trained on. This is one example here, which is quite unfortunate. This is a research paper here that was published with a co-author of ChatGPT. The journal eventually redacted it and said it was a mistake, that ChatGPT was an author. But we've got to worry that more and more, actually, our generated content is being generated by machines and not by human. And it's quite sad that it can happen with research. So this is some analysis that happened on PubMed, the medical journal, and they actually found that the word delve has rocketed over the last couple of years. And the reason for this is that the training data, the humans that they got to train in step 2 were from, I think it was Nigeria. And in Nigeria, the word delve is quite a common word, where in many other countries, like in the UK and in the EU, the word delve hardly ever appears in a research paper. But because the trainers in Nigeria identified that word, then that word became a common word overall. So these were some of the other words: commendable, innovative, intricate, noble, versatile, and meticulous. Have hardly appeared in research papers in the past, but now they actually appear as quite common words. So the other thing we need to do is to understand if LLMs will replace us in some sort of way. And this research here looks at the peer review process where peer reviewers for research papers are using AI to be able to generate the peer reviews. That's really worrying because an AI at the current time cannot tell if some piece of research is novel or not. They can tell if the spelling is good, the grammar's good, the layout's good, the images look good, and so on. But they cannot tell if a piece of research is truly novel because they don't understand the subject areas and reason. So this paper here outlined a study that looked at a conference. And what they found was these words here had a fairly high probability against what you would expect from previous things. So delved is there, bolster, delves, necessitating, are all words that have hardly appeared in the past in research papers. So they actually found that there was an increase in AI-assisted reviews, about 17% of them. So they estimated that about 15 to 16% of the papers were peer reviews came from AI. They reckoned that AI produced a higher score for the review. So if you were lucky to get AI to review your research paper, you actually had a better chance. And that the AI generated reviews for the research papers generally had a higher points average for the score of the paper than a human reviewer, who typically tended to be more negative because they were probably looking much more at the content and the contribution of the paper. So one of the core weaknesses that we have within our LLMs at the current time is hallucinations. And hallucinations are a problem because if the AI doesn't know the answer to something, it will just guess and take a random guess based on its probability. And that's a problem because if you're speeding along in a car and a dog goes out in front of the car, then what happens if the AI gets that decision wrong from there? So we define this as a hallucination. And there has been published work on this, and really we've got to define that the actual LLM doesn't know it's getting it wrong. All along, it can't reason to the answer, and what it is it's actually defining the probabilities of the best answer that it can get. But for us, we would actually see that as hallucination or even a lie that something isn't actually quite true. So if we ask it for something fairly standard, like what's elliptic curve cryptography, it's fine, it's great. And we ask it a bit more details, everything is fine about its answer. But then if we go a little bit deeper, like we ask maybe about me here, then most of the things are quite correct because it's managed to crawl my data from Wikipedia and so on. But then when I ask it what subjects I teach, you actually find it saying software engineering, which I don't teach anymore. Most of the topics are correct. It's starting to hallucinate and starting to lie, as we would say. If I ask it what contributions I've made, then it completely lies in that this is nothing that I've ever done at all, and this method doesn't actually exist. Then it talks about my work in power grids and transportation networks is a complete false lie that I don't do any of these things. So the AI is starting to hallucinate. When I ask it what car I drive, then it doesn't tell me. When I ask it about what I invented, unbelievably, it says I invented the hypervisor. If I'd invented the hypervisor, I'd be a multi-billionaire at the current time. I wish I had invented the hypervisor, but I have. And then it says about a malware genome project. I have no idea what that is at all. So once you start to move deeper and deeper, it's pretending that it knows, but really all it is doing is using its learning from this. And then I asked it what my best research paper was, and these are complete fake papers that I've never produced in my life. I have no idea where they actually come from at all. It's a complete hallucination. So you probably know lots of the Gen AI tools around, uh, but what I'll do is I'll just introduce them just in case there is any gaps. We probably all use Gen AI, and we have our favorite one from there. So generally, OpenAI has these sets of tools, but we can use Gemini, we can use the open source Llama Meta model. DeepSeek is popular in the world, Claude, especially in the EU, and Grok is from Twitter or X. Okay, so there are many competing models that we can have for our Gen AI. For ChatGPT, then we have obviously a web interface, or we can have Python or any other code, and it will generally produce good models for us. 4.0 is a fast model, which is fairly accurate overall. Then we have DALI 3 within inside OpenAI. So for this, it's pretty good. You can have a style. I've got a manga style here, and you can have a blackboard, a llama, two robots, Bob and Alice. And through this tokenization, it can actually understand that it needs to create an image with Bob and Alice, two robots, a llama, a blackboard, and a manga style. So it's pretty good. And the way it does this is it starts with noise, and then through neural networks, it builds up a picture that starts to look like the image that we've asked for. And the advantage with this is that because it's generative, every time it creates a new image, it will be a new image, and hopefully it shouldn't be copyrighted in there. So then we can also use diffusion models, which are open source. So I'll leave the Python code for you if you want to run this. But in this case, I'm running it on a Mac, so you typically have to run it on a GPU. And because MacBooks actually have GPUs in them, then you can actually run this on a Mac. So in this case, we're using this diffusion model. Typically, we get this from Hugging Face. So Hugging Face has lots of models on it. We download the model, and then we can run it locally on a machine rather than using a closed source model. So when I asked it for two robots with a blackboard, then unfortunately it wasn't great. Okay. So there's a big difference between the open source models. I mean, this one here has a llama and a person, and I think that looks like a blackboard, but you can see it was nothing like the OpenAI model that we got from DALI 3 there. So the open source models are still not as good as the closed source ones, but they're improving all the time. Okay, and then when I asked it for a portrait, so this is looking for an image here, then unfortunately it wasn't great. So I asked it for a photograph of a cybersecurity professional, and I don't know if you see, but they're all male, they're all white, they've all got glasses mainly, and they all look a certain age and so on. So obviously the training data on this model has been limited in its diversity and so on. When we look at doing this with DALI 3, it will ask us for gender, clothing style, backgrounds, and so on. So OpenAI is much better in trying to represent the entity that you actually want, and will produce a really excellent image here. Okay, so you've really got to watch what your training data is and whether it's diverse and representative of entities. And we can see with this open source, that's not very good overall. So obviously a worry for us is that in cybersecurity, as we now move towards a deep fake world where you can't trust anything in the images that you see, the video, the sound, and so on. So this is
way that none of those
a deep fake
failures of the
example here.
past would
One
recur
thing
because
that
just the
you should be able
physics
to
of how it's
see
built.
is
This
that
is
the
deep
mouth
fake example of what is
is
possible with
not
powerful
quite
computer and editing. It took
as
around
rendered
72 hours to create this example from
correctly,
scratch using
but
extremely powerful
that's
GPU.
improving
It could improve with more computing time, but 90%
at
people
the
cannot
current
tell the
time.
difference.
Over 98% of people can't tell the difference between a deep fake and a real person. And it happened, there was a hack for 25 million where all of the entities on a Zoom call were deep fake avatars and so on. So it's really going to increase in its scope. And we start to see videos like this, which is quite worrying. And you can see how politicians are extremely worried with this type of content overall, in that what it could actually produce. I mean, isn't that an adorable little baby there? But that's all being created through a deep fake videos. Again, we start to see things online that we really can't tell if it's real or not. Everything looks correct. So we're moving into really a fake world of content. So Sora is the OpenAI tool. So in this case, we can see it's beautifully created video content, and that was created with a simple script such as this. So we're actually starting to see high definition video being created. This was a little video that I did on Sora. You can see that it looks pop art, everything's fine, but the text isn't rendered correctly here. But it's managed to make a reasonable attempt at it. So this was the text that I put into Sora, make a video of Bob and Alice in a pop art style. It got that right, where Bob is saying, "Hello, I'm Bob," and so on. You can actually see that it's still struggling to get the text right for the video. But now it is possible for anybody to be able to create high definition video with Sora. And then we're starting to see Whisper. Whisper is the AI tool, and it's reckoned that you can take 15 seconds of a sample of someone's voice and then replicate them singing a song or saying anything that you actually want. This is an example here of Johnny Cash singing Barbie Girl, which is all rather sad, but if you listen to it, you would not know the difference between Johnny Cash not singing it.
Hello.
So can we detect the machine? So if we see content, can we detect when the machine is actually there? So really that's related to the singularity. And a recent research article did a Turing test for human versus machines. And it goes back to this paper here, As We May Think, that talked about the singularity, the time at which machine intelligence was more intelligent than humans. And if you think about it, then really we have a massive increase in our generations of Gen AI. So we went from 175 billion parameters to 170 trillion parameters with ChatGPT-4, a massive increase in the number of parameters and the scope that it worked with. So these were the tests. So this is with ELIZA, which is a very old 1960s, 1970s model of AI. And most people could actually determine that it was a machine and not a human. Unbelievably, some people still thought it was a human. I don't know why they would think that. ChatGPT-4 just about got to the 50%. At the 50%, then more people are thinking the machine is a human and vice versa. So in this case, there was a 50%, but it was shown in ChatGPT-4 that more people thought the human was the machine was a human than did not. So we've passed the point of singularity. When it came to the human, obviously, most people thought that the human was a human. A few people thought they were a machine. But it's a 5-minute test that they actually did. So here are some of the responses. And I know it's a bit difficult to see from the screen, but you can see here it's very rough language, not really good grammar, spelling, and so on. This is likely to be the human. But when we look at something that has good grammar, such as using the question mark correctly, then we're actually probably looking at a machine here. Okay, so the days of us actually differentiating a human from machine with bad grammar and spelling and so on are gone. We are worse than the machine now. So these were some of the traits that actually identified whether someone was a bot or not. So we can see here when it came to logic and maths, current event, then that was a good differentiator for a human. Again, these are good differentiators for humans, where these are not. If you ask it about the weather, it'll probably tell you what the weather is quite good because it can search online. So we need to understand the types of questions that we need to ask our AI to be able to differentiate it. So when it came to things that looked like an AI, it's a forced persona, too informal, lack of personality, weird tone. And when it came to a human, it was generally that it just felt like a human tone, informal, plausible. Spag is spelling and grammar errors. So the humans tended to have more errors, and they were typically slower at typing and responding and so on, where the machine responded fast. But remember that people who are writing the AI will actually start to write bad spelling and so on to make it look more like a human in them. So what we have just now is that we have closed source models such as Gemini, OpenAI, and so on, but we can also use open source models. So these are models that we can download from Hugging Face and are available to run as a standalone. So with that, we don't have the constraints of running within the cloud and so on. We can use any model that we want. In fact, we can train our own model. So these are open source models overall. So one of the most famous is Llama 3 by Meta, and it has been trained with a large amount of parameters, up to 70 billion parameters now. Not as good as OpenAI with its trillions of parameters, but 70 billion parameters is a lot. So this puts AI in the hands of every single citizen and every single cybersecurity attacker on the planet. So you can download Llama onto your Windows machine or onto your Mac. Just let me grab my console here. So we can I can list the models that I have, and then I can download. So with Ollama, we have a command line and also Python integration in there. So Ollama will allow us to be able to pull a model. So from the repository, we can pull either the smaller model or the bigger model overall. I can list the models that I've got on here, and you can see I've got the latest 4.7 gigabyte model there, or I can use the 70 billion parameter model. It takes up 40 gig of space on my machine. Okay, so what I'll do is I'll just I'll run the small model, because if I run the big model, it will actually take a while to actually run. Okay, so what will I ask? How does elliptic curve cryptography work from there? Okay, so this is running locally on my machine here. So there we go. That's pretty good. It's giving me a good answer there for that. Okay, it goes into. So the advantage with this isn't actually costing us anything at all, and it's running locally on my machine overall. So I can just quit that, and then which is better for digital signature, RSA or ECDSA. Okay, so basically it's been crawling from Stack Overflow and places like that, and managed to get good answers from there. So at the current time, we can't generate images from this. Llama 3 is basically just for our text. Okay, so you can see it's pretty fast overall, and we can easily integrate this with Python. Okay, so if you have a Mac, then you can download Ollama onto your machine, such as from here. You can do that now if you want, and then you can actually show the model that you have. We can see there are 3.2 billion parameters there overall. Okay, so this is me running the Llama 3 here. Okay, so we can easily integrate this into Python. So with Python, you just have to download pip install Ollama, and then we can actually integrate our code into there. We'll leave the source code for this on the GitHub and also Moodle so that you can actually run it. So when I tried this one, it wasn't great because actually it didn't quite understand what ECC was. So you've got to watch that it's not quite as good as OpenAI in interpreting acronyms. In this case, it's linked that to ECB mode, which is a symmetric key encryption mode. So there's a bit more playing with it and a bit more filtering that you have to do in the front end to make sure that it's actually getting the prompts correctly. Okay, so as a final topic, let's look at some automated security. So are LLMs going to be used in cybersecurity operations? And the answer is certainly yes. The main area that they're good at is taking lots of data and then filtering it out to present to humans in some sort of way. It's unlikely that we would ever in the near future replace humans inside this complex area of cybersecurity. So these are some of the research papers that are focused on creating using LLMs within cybersecurity. This one here is interesting because it will take logs from our system logs, and then it will then map that to the MITRE tactics. So just like a GP will look for certain symptoms and find a diagnosis, then an LLM actually looks for various signs of an intrusion and then can map it to what's called the MITRE attack framework. Okay, so basically in a cybersecurity system, we have lots of logs that will feed in, and then that goes into typically be seen by level 1 SOC analysts who will then filter that. We're also getting internal context about our network and also external. So LLMs are quite good at taking all of this data and making some sense of it and then presenting it to humans. So this is a range of attacks that we would have in cybersecurity: cross-site scripting, command injection, and so on. So one research experiment, and this is only one experiment, and it was done by the company who has this product, looked at creating an LLM to detect the vulnerabilities as opposed to a human. So they took a junior person, someone who's more senior, more understanding of cybersecurity, and then a principal person who's someone with extensive experience of penetration testing and so on. And they actually found out that the LLM was as good as the expert, But when we drill down a little bit more, we actually see that it was very good at taking the easy tasks, but actually when it came to the hard tasks, like with intrusions that weren't seen before, then it really struggled with that much more. So it looks like for the easy attacks, for the scripted attacks, the LLM could do things fairly well in an automated way. But when it comes to more complex attack patterns, then the human is still the strongest there. Okay, so when it comes to automated security, obviously we need to we can look at different architectures for this. So this is one research paper that outlines how you could create a completely automated infrastructure using Gen AI. So here is the honeypot. We've got information sharing and privacy. All are run through some sort of Gen AI infrastructure in there. But obviously, one thing that's on the rise just now is the rise of agents or AI agents. So these will be task orientated. So they will have one task to do and they'll do it really well. And then we can have lots of different AI agents doing lots of different tasks and all working together, just like we would take a complex task and split it up into smaller parts. In this case, Bob has an AI agent. He tells the agent to get a copy of his passport, book a flight to Rome, and delete old versions of my files. The AI agent then perceives what he wants and then reasons and then calls up an LLM and actually books the flight, gets a copy of his passport, and so on, and then can obviously act on that. And overall, we'll learn each time it does a certain task, and if it does it correctly, then it learns a little bit more. But we can see here it's a bit vague, delete all old versions of any of my files. So if the AI agent wasn't constrained, it could go and delete all of his old files from his disk. So we need to watch that we constrain the AI agents into what they can do, and so that they don't jump out of that and can run wild. So this is one model that we could have, is that here Bob speaks to the LLM. The LLM then codes that into a policy, a XML policy that would be enforced in a secure enclave. So when Alice wants to read the document, she will have to prove that she's in a certain location, in a certain time, and so on. So in this way, we could use the AI as a first interface to be able to translate into a core security infrastructure and for that to be enforced. So when it comes to testing, then obviously we've got to change the type of testing that we do on our AI agents. When it comes to an autonomous attacker, there'll be no kill switch in there that we can stop it. There will be no human interventions, possibly, no tracing or attribution of the attacker, and no limits on the action. But when we use our AI, we need to look at our different types of testing. So our red team testing is to look for prompt injection, as we saw, goal misalignment, sandbox escapes, and hallucinations. What happens when a hallucination happens? What action happens after that? And then we need to be able to audit everything that the AI entity is actually doing to make sure that we trace when it does something that's wrong. And we need a kill switch architecture where we can stop the AI agent at any time if it's doing any damage, like deleting all our files and so on. We also need to define the rates and the boundaries that the AI agent exists. Don't allow it to change the admin password, whatever you do, because if it changes the admin password, you might not be able to get back into your system. Prevent lockout, make sure that you can kill it, have boundaries, and have an air gap if you can between the real world and the sandboxed AI entity that's actually running. And critically, keep the human in the loop. The human should be there to always check, make sure, validate, and prove that things are actually correct. Okay, so that was a quick introduction to AI and cyber.